Hi everyone. Good evening, guys. Everyone, how are you all? All of you had your snacks, tea, coffee, evening snacks, tea, coffee, everyone? Or nothing you had? Simply sitting. Okay, right. So here we'll be continuing our discussion on this state PSC PYQs, right? Successfully we have completed how many topics? Two topics we have completed. That is fundamentals of this surveying we have done, and at the same time, what else we have done? The chain surveying, linear measurements also we have completed. It's not linear measurements with the chain surveying as well as what the tape, you can say chain surveying. Tape is also a part of chain surveying only. You can say linear measurements only that we have done. It's not. Right, now we'll be entering into the next chapter, that is compass surveying, all of you, right? So many of you are eagerly waiting now. After compass survey we'll be entering into this theodolite topic, you can say, if you just observe, right? Isn't it? Right, now all of you, welcome to Unacademy. Let's crack it. Everyone ready to crack, all of you? Everyone is ready to crack, all of you? Yes, everyone get ready to crack. Don't miss cracking. Right, always you have to think like that. Let's crack it, let's crack it. Then automatically positive vibes will come into your mind, and it will not deviate, right? Yes, Lina, good evening. Always you have to think like I will be cracking, I have to crack. That you keep in mind always, right? So that will help you, right? That will help you to work towards the success always. Yes, na? Right. So whenever you are using whenever you are subscribing for any plus and iconic courses, use the referral code this RPC live. Okay. So this is my profile, you can follow me, and this is the referral code you have to use always, right? These are all the subjects I'll be taking. And there is very important announcement, that is Unacademy Ultra Combat event is going to start. So when it is there on April 24th 11 a.m. right? It is there on April 24th 11 a.m. So use the invite code RP Civil Live. Use the invite code RP Civil Live and subscribe, and enroll for this, right? You can find the link for this Ultra Combat event in the description of this video, right? And what is it you can say? Previously normal combat, weekly combat means only 100 students, first 100 students can get chance of scholarships, is na? Next one, mega combat means 500, first 500 students will get na, and this is ultra combat, right? What is this ultra combat? You can say ultra combat event is nothing but top 1000 students will get a chance of 100% scholarship, right? So don't miss this, all of you, right? This GATE and ESE rankers summit will be conducted at weekends by top educators will be having interview with which one? This people, right? Rankers, and these rankers will be guiding you in all aspects, you can say, right? So you get ready for last steps of your success, all of you. Don't miss this, right? These are all, yeah, because good evening. Now these are all which one? This GATE 2022 toppers from Unacademy, and these are all ESE 2021 toppers from Unacademy, you can say. Right, now these are the new batches starting, right? When these batches are starting, if you just observe, irrigation engineering at 7 a.m. by KP sir, right? Krishna Prakash sir will be starting on which one? April 20th, right? Don't miss this, all of you. What is that referral code you have to use? Use the referral code RP Civil Live. Okay. Now Spark batch. So whenever you are going, this is also started by this KP sir, Krishna Prakash sir. What is the referral code you have to use? RP Civil Live is the referral code you have to use. Okay. Don't miss this. Now these are all the differences between plus and iconic subscription, right? So these benefits you will not get in plus, right? These benefits you will not get in plus, only these benefits you will get in which one? Iconic subscription. Okay, you have to be careful, don't miss this. And Unacademy Lite subscription, right? Unacademy Lite subscription is nothing but it is only test series related, right? Naveen, good evening. So now coming to this YouTube live class on this surveying All-State PSC PYQs, right? We'll be doing this All-State PSC PYQs of surveying until All-State PSC PYQs of surveying all chapters gets over. Okay, will not stop in between, right? But you have to maintain regularity, that is important, all of you. Right, now coming to this chapter 3, compass surveying, right? Compass surveying, and first part of this compass surveying, that is your basics and definitions. Okay, basics and which one? Definitions. We'll be just looking into this basics and definitions only, right? So don't miss this. Yeah, try to select the answer, all of you. 159th question is waiting for you. Select the answer, everyone. question is waiting for you. 159th question all of you. Write the question number and answer. Write the answer. Not writing the answer, all of you. Lina said C and Vikas also said C. Yes, 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 absolutely correct. Right? What is it you can say? In a prismatic compass, right? In prismatic compass, what will happen? Magnetic needle and graduated circle is fixed to each other. So this magnetic needle is free to rotate or it is not free to rotate, you can say. And generally it is not D, it is which one? This is C, right? So now tell me, so is this a magnetic needle always in the north-south direction? When magnetic needle is always showing that north direction and this south direction, how can you get this? You can say, if you just observe, how can you get the readings? You cannot get the readings, na? Yes or no? You cannot get the readings, right? Isn't it? So what is that? Magnetic needle and graduated circle is fixed to each other, right? Magnetic needle and graduated circle are fixed to each other, you can say, right? So they are not moving, right? What is that you can say? Prismatic compass, graduated ring is attached with the needle. The ring does not rotate with the line of sight, right? So that ring will be rotating with the line of sight, or ring will not be rotating with the line of sight. That ring will not be rotating with the line of sight. You have to be careful, okay? In surveyor's compass, it is different, right? That line of sight, magnetic needle will be rotating along with the line of sight. Yes, na? Right. God, namaste. 160. Select the answer for this question of you. Once done, tell me everyone. Yeah, chapter 2 PDF, I'll share it. Password you remember, right? Linear is the password for chapter 2 na. Okay, I'll share it in my community and in groups I'll be sharing. Okay, don't worry. This 160th question, select the answer of you. Write your answer. Today I have uploaded this 15 questions, so we'll try to complete mostly 15 questions, right? It depends on how fast you will be answering. Okay, so we try to answer fastly and we'll try to move fastly. Problems will come later. Okay, Lina, problems will come after that. Okay, first we'll discuss about which one? First we'll discuss about which one? First we'll discuss about this theoretical questions. After that we'll go for the numericals. Yes, na? First basics and definitions only. The heading I have given na, basics and definitions only, right? After that, after these questions from these basics and definitions gets over, we'll be entering into which one? This is a numerical type. Okay, yes, na, Lina? Select the answer for this. D, 160th D. Any other answer by others? Naveen, Lina, Vikas said D. Any other answer by others, all of you? Yes, what is that you can say? The dip of a magnetic needle is inclination with the ground surface. Is it the inclination with the ground surface, all of you? Dip is nothing but which one? It's the inclination with what? Dip of a magnetic needle is the inclination with the ground surface, right? Is it inclination with the ground surface, everyone, if you just observe? No, it is not the inclination with the ground surface, right? then in the northern hemisphere, the north end of the magnetic needle is deflected downwards, right? So with respect to this poles, how much declination you are having, right? Northern hemisphere, north and north attraction will be there, repulsion will be there. Already this is northern hemisphere and it will be deflected towards which one? This downward, na? Yes or no? It will be deflected towards downward definitely or not? Yes. So what is that? A dip is 0 at equator, na? If you just observe first one, what is a dip at which value? Dip at this equator is how much? Dip at this equator is equal to this 0, and dip at poles. So dip at poles, right? Magnetic poles, right? Okay, yes, right. Dip at magnetic poles is how much? This 90 degrees, na? 90 degrees, na? Yes or no? Dip at equator is 0, and dip at which one? This magnetic poles is, right? Magnetic poles is which one? At magnetic poles it is 90 degree or not? Yes, at magnetic poles it is 90 degree, you can say, right? Is na? Is that clear? Right? So what is that? When the magnetic needle is freely suspended, right, takes up to a position parallel to the earth magnetic line, then its horizontal projection defines the magnetic meridian and exhibits the direction of the magnetic north and south, right? If you are just suspending it freely, what will happen? When you are suspending the magnet freely, when you are suspending that magnet freely, what happens? It will be showing that north and south directions, right? North and south directions, and its projection on the ground will be representing the magnetic north and magnetic south, right? Yes, na? So here whenever you are considering dip at the equator will be 0. Dip is the inclination depending upon what? It is the inclination depending upon what? It is the inclination depending upon which one? Tell me. Anjanelu, you tell me. What is a dip first of all? First tell me the definition of this dip. Tell me. First of all, what is the definition of this dip? Anyone? Anyone can tell me the definition of this dip? Then you can understand. If you know the definition, you can understand what is the, right? You can understand, right? You can understand. Angle, which angle? That is what I am asking, Lina. Okay. I am asking what is the meaning of this dip, right? What is the definition of this dip? No, that is declination, Lina. True meridian and this magnetic meridian, right? Angle between the true north and magnetic north, or true south and magnetic south, true meridian and magnetic meridian, that is a declination, okay? That is a declination, not a dip, you can say, right? That is a declination, not a dip, okay? Is that clear? That is a declination, that is not a dip, okay? Right? Is that clear? Right. No, okay, I'll be writing the definition of this dip, don't worry. I'll be writing the definition of this dip, right? Dip is nothing but, right? What is a dip? Nothing but it is an angular inclination. Yes. Anyone? Yes, that's why confusion in theory. Sir, declination and dip are both are said. Now you got, see, angle between the magnetic meridian and true meridian is declination. Then what is that a dip? Have you got this, all of you? Have you got this, all of you? It is the angle made by which one? It is the angle made with what? It is the angle made with the horizontal of earth, right? It is the angle made with the which one? Horizontal. It is the angle made with the horizontal by which one? By the earth's magnetic field. By which one? By means of this earth's magnetic field. So whatever it is, the angle made by this earth's magnetic field with the horizontal is called as your dip, right? Yes, no? What is that? Why it is occurring? Why it is occurring? It is an angle made with the horizontal, right? Angle made with the horizontal by the earth's magnetic field, right? So this is your earth, let us say. this is your horizontal, right? What is happening if you just observe it? What is happening if you just observe it? These Earth's magnetic field are like this, na? Yes or no? This Earth's magnetic field will be like this, na? At the poles, what will happen? Whenever you are observing, right? Whenever you are observing at these poles, right? What happens? You are see, these are your Earth's magnetic field, right? These are the lines of Earth's magnetic field, but this is a horizontal, right? This is a horizontal, right? By the time these poles comes into picture, what happens? By the time these poles comes into picture, almost these magnetic lines in this vertical manner, na, and this is your horizontal manner, na, so angle will be 90 degrees, na. But whenever it comes to this equator, if you just observe, almost that horizontal and this magnetic field will be coinciding, na. This is your horizontal and these are the magnetic field lines, both will be coinciding. Then what is that you can say? Angle, dip angle at the equator will be 0 and dip angle at the poles will be 90 degrees, right? Horizontal angle between the horizontal and the Earth's magnetic lines, Earth's magnetic field lines. Okay, is that clear now? Is that clear now, everyone? Why it is occurring actually? Because whenever you are considering any angle, right? Whenever you are considering any magnet, it will try to be in align, right? It will try to be in align with what? It will try to be in align with the Earth's magnetic field, right? That is why these kind of situations are happening, right? So upward, downward angles, na? Yes, upward, downward angles, right? So what is that you can say? When the compass needle is pointing downward in the northern hemisphere or upward in the southern hemisphere, right? So whenever it is pointing, 1 second, I will be just adding that point. Shall I add those points, all of you? Shall I add those points, everyone? Yes, I'll be adding those points, 1 second, so that you will not have any problem then after that. So here this dip occurs due to which one? Dip occurs because reason. So dip occurs because which one? Because any magnet, what it will do? Will try to be aligned with what? Try to be aligned with which one? Try to be aligned with what? Yeah, try to be aligned with which one? Try to be aligned itself with, right? Try to be aligned itself with whom? With magnetic lines of this with whom? With the magnetic field lines, na? With the magnetic field lines or not? Yes, with the magnetic field lines, if you just observe, isn't it? With magnetic field lines, if you just observe, right? Isn't it? With the magnetic field lines, if you just say, right? Isn't it? Right. And if you just say, right, and if you just say, right, whenever it is, right, whenever it is in the northern hemisphere of this one, right? Let us say whenever it is in the northern hemisphere, right? This is your north pole and this is your south pole, na? So the top portion is your northern hemisphere, na? Whenever it is a northern hemisphere, it will be dipping towards up, na? Yes or no? So what is that you can say? As the Earth's magnetic field lines are not parallel to the surface, right? Are these Earth's magnetic field are parallel to the surface of the Earth, or they are not parallel to the surface of the Earth? They are not parallel to the surface of the Earth, na? Yes or no? So what is it happening? At the north end of the compass, right? So what is happening? North end of the compass. North end of compass, what it is happening to this? North end of compass needle. North end of this compass needle will point downward. Will point downward in which portion? In which portion? In a northern hemisphere, na? North end of this magnet will try to point downward in the northern hemisphere, right? Why the north end of this magnet is pointing downward? Why it is not pointing upwards? Because if you just observe, north and north both will attract or repel. They will be attracting towards each other or they will be repelling towards each other, right? They will be repelling towards each other, na? So already Earth's biggest north is there. Therefore what will happen in the top portion? South of this magnet will come at the top and the north of the magnet will come to the bottom, right? Same poles will attract, or north north will attract, or north south will attract. North north will not attract na. Earth north is there already at the top, so it will be attracted by which one? This magnetic south. Okay, it will be attracted by which one? This magnetic south, right? And in the southern hemisphere, what is happening? That north is pointing upwards, north is pointing upwards, or north is pointing downwards, you can say. North is pointing upwards, right? If north is pointing upwards in the southern hemisphere, right, what will happen? Whenever the north is pointing upwards in the southern hemisphere, then it is which one? Then it is which one? Then it is negative dip, you can say, right? Then it is a negative dip, then it is positive dip, you can say, right? Yes, now. So north end of this compass needle will point down in northern hemisphere, right? It is called as your which one? This is positive dip, na? Yes, it is called as your positive dip, you can say, isn't it, everyone? Right? Isn't it, all of you? Like that, you can say, right? Is that clear? Yes, reflective, na? So that is what, right? What is the reason for this? What is the reason for this? Magnet, na? Now if you just observe, in a northern hemisphere, the north end of the magnetic needle deflected downwards, right? Is that clear, everyone? The second point. Dip of a magnetic needle is its inclination with the ground surface. Its inclination with the ground surface, or its inclination with the horizontal, all of you? It is not its inclination with the ground surface, its inclination with which one? Horizontal, right? Its inclination with horizontal, right? Not the ground surface, right? So first statement is absolutely wrong, na? Yes, second statement. So first statement is wrong means option A is wrong, option B is wrong, right? Among C and D only we have to select, right? In southern hemisphere, the north end of the magnetic needle deflect downwards, right? Is it deflecting downwards, or it is deflecting upwards? Northern hemisphere, it is deflecting downwards, means southern hemisphere, what will happen? North end of this compass needle will point upwards, na? It will point upwards in which one? Southern hemisphere, na? It will point upwards in which one? This is southern hemisphere, right? Then it is called as positive dip or negative dip, you can say. It is called as your negative dip if you just observe, right? Is that clear? It is called as your negative dip, you can say, right? Isn't it? So northern hemisphere, it is pointing downward, correct, but southern hemisphere, it is pointing upwards, right? That third statement is wrong. Option C is also wrong, then option D is only correct. Without checking, right? Without checking this fourth point itself, we can go for this option D, na? The amount of dip varies in different parts of the earth. Now tell me, yes, absolutely, na? Will it be correct? Will it be same everywhere, or it will be different at different locations of the earth? It will be different at different locations of the earth, na? It will be different at different locations of the earth. Okay, is that clear? Is that clear, everyone? Yes, na? Right? Now coming to this 161 question, select the answer of you. It's 161 question. Yeah, north upward means negative. Yes. Northern hemisphere, if it is pointing upward means it is negative, obviously, right? Select the answer for this question of you. First we'll complete the theoretical questions, then after that we'll go for what? Numerical questions, okay? Raviraj said A, Leena said C. Any other answer by others for 161 question? In surveying measurements, the bearing taken in a clockwise direction with respect to this magnetic north is referred as, right? With respect to this magnetic north, right? What is that you can say? That is your magnetic north, you can say. With respect to this magnetic north, what is that a bearing or angle measured in clockwise direction? So this is, let us say this is your line AB if you just observe, right? For this line AB, if you are just measuring this, right? What is this angle measured in the clockwise direction? This is your which one? This bearing, na? Magnetic meridian. Magnetic meridian is nothing but your magnetic north, na? So true meridian is nothing but your true north, na? But it is not, right? Reduced bearing, no, it is whole circle bearing. Yes, correct, absolutely, right? What is this you can say? This is your whole circle bearing directly, na? Yes, it is your whole circle bearing, Anjanelu, right? Magnetic meridian is nothing but magnetic north, Anjanelu. Magnetic meridian is nothing but magnetic north. But what is mentioned? Bearing taken in clockwise direction. Bearing and meridian both are different, na? Bearing and meridian, right? Bearing and meridian both are different or not? Yes, bearing and meridian both are different or not? Bearing and meridian both are different, na? Yes or no? Bearing and meridian both are different. If you just update, bearing and meridian both are different, you can say, isn't it? So bearing and meridian both are different means this is your meridian reference point, and inclination of any line with respect to meridian is your bearing. Okay, Anjanelu, is that clear? You have to be careful. Meridian is the reference line. Meridian is a reference line. No, it is magnetic only. It is magnetic meridian only. It is magnetic meridian only. Okay, magnetic meridian are with respect to magnetic north, right? Magnetic north or magnetic meridian. With respect to this magnetic north or magnetic meridian, the angle taken, right? The angle taken by this is which one? Angle made by this line with the magnetic north or magnetic meridian is whole circle bearing only. Okay, and nearby poles, nearby south or north is which one? That reduced bearing, you can say. It's not right. Now select the answer for this 162 question. Yes, na? 162 question. Select the answer, everyone. Done, everyone? B. Durgendra, Leena, Raviraj said B. Vikas also said B. One 62 B. Everyone? Right? Oh, so what is that? The standard meridian of this India is, right? What is the standard meridian of this India? It is 82.5, 82.5 degrees, na? Where it is passing through, if you just observe, is it not passing through this Prayagraj? 90 of Prayagraj, right? Prayagraj, right? What is it? Prayagraj, we can say. Can we say that Prayagraj is nothing but your Allahabad, Allahabad? Any name you can give it, na? Prayagraj, right? So this is towards east or towards west, if you just observe. 82.5 degree, right? 82.5 degree towards east, na? Yes, 82.5 degree towards east, right? Towards east, right? Towards east from what? Greenwich, na? Towards east from this Greenwich, right? And it is a positive, right? Plus 5.5 hours, right? Plus 5 hours and 30 minutes, right? Plus 5 hours and 30 minutes, right? Plus 5 hours, 5.5 hours, right? 5.5 hours faster than which one? Advanced, or faster or advanced than which one? Greenwich mean time, na? Faster than this Greenwich mean time, right? Actually in India, before Britishers and Mughals came into India, what was the reference line we have taken in India? It was taken as what? It was taken as Ujjain, right? Ujjain Mahakaleshwar temple is there, na? So that Mahakaleshwar Jyotirling has come based on that only, because Kal means time. Time is taken a reference to Ujjain for the entire world previously, before Mughal and before very long back, you can say. Because it was measured with respect to Ujjain, that Kaleshwar temple has come into picture, you can say, right? So, but now in the modern era, we are taking which one? This the 82.5 degree one we are taking, na? We are not taking that to Ujjain, okay? It is changed right now. Select the answer for this one. 163 question. Select the answer here, everyone. Raviraj said yeah. Don't know. this is your sun fellow, let us say, right? That fellow is which one? Sun fellow. And earth will be rotating around the sun in this elliptical path only, no? Earth will be rotating around the sun in its elliptical path only, or not? Yes, it will be rotating in its elliptical path only, like this you can say, right? Now tell me, the earth is rotating exactly in this vertical manner, or it will be not rotating in a vertical manner? It will not be rotating in a vertical manner, it will be slightly inclined like this, na? It will be slightly inclined like this, right? By which angle it will be slightly inclined, you can say? By this 23.5 degree, right? By means of this 23.5 degree angle it is inclined, right? So 23.5 degree, or you can also say the exact value as which one? This is 23 degree, that is 27 minutes, yes, not? Yes, isn't it? So this is, it is not exactly vertical, right? Instead of being vertical, it is just rotating like this, yes, not? It is just rotating like this, if you just, right? So what is angle? What is the inclined angle? You can say this is your 23 degree, that's 27 minutes, right? Almost 23.5 degrees. Okay, this is option A is correct, right? Like that. Earth is not rotating exactly vertical, right? It is just inclined. It is just inclined. You have to remember this value. You have to mug up this value. That's it, right? There is you have to just remember this value, right? You have to just remember this value. Okay, right. Now tell me 164. This one. 164. Raviraj said ready, and any other answer by others? Lina also said ready. Sorry, did I move forward? Yes, yes, 164 question. This na, I was confusing. Arey yaar, it should be bearing, and it is changed suddenly. What is this? Okay, okay. This question, 164 question. That is why you have to write the question number. Okay, write question number and answer. Right, write question number and answer. Okay, write question number and answer for this 164 all of you. A bearing of a line is also known as magnetic bearing. Na, by default, bearing is nothing but your magnetic bearing only. Okay, by default, which one it is? If you just observe, by default, that bearing is equal to that magnetic bearing only. Okay, right. Now tell me the answer for this 165 question, all of you. Declination, I have already said the answer for this declination. Yeah, 165th question, select the answer of you. One 165C, Raviraj, and any other answer by others? Any other answer by others, all of you? Raviraj, you already said, no problem, no need to say again. Others I am asking. Magnetic declination, right? What is that? You can say this is your true north, na? This is your true north, you can say, right? True north or true meridian, right? True north or true meridian, you can say. But what happens, this magnetic north or this magnetic meridian, right? This is your magnetic north or magnetic meridian, right? Suppose if it is inclined towards this east, right? This is called as your which one? This is declination, right? What is this angle called as? This is called as your declination angle. Okay, this is called as which one? Declination angle, if you just say, right? Declination angle, we can say, if you just observe, right? Isn't it, everyone? So deflection of the magnetic needle due to the earth magnetic source, no. Error in the bearing due to angle between the true meridian and the magnetic meridian at a place is called as your magnetic declinations. Now options will be the correct one, right? Like that. Now tell me 166 question. Select the answer for this. Write the question number and answer so that I will not be confusing, because from my voice to your voice there will be some 5 to 10 seconds gap na, and your answers to my observation also 5 to 10 seconds gap is there, so I don't know which question you are answering, right? Write the question number and answer, okay? Write the question number and answer so that I will not be confusing and others also will not confuse, okay? That is why I am asking every time. What is this? What is that azimuth? Azimuth is nothing but your true meridian, right? This is nothing but your which one? This true meridian, right? It is your true meridian or true north. Okay, true meridian or which one? This is true north, you can say, right? So if it is an azimuth, magnetic azimuth, you can say, right? When you are taking it as magnetic meridian means it will be magnetic azimuth, you can say, if you just observe, right? But by default that azimuth means it is true north only, right? It is true north only. It is not arbitrary. Okay, you have to be careful. It is not arbitrary. It is true only, right? You can say it as arbitrary meridian, you can call it as, but that you cannot call it as azimuth. Okay, that you cannot call it as azimuth, you can say. Okay, that you cannot call it as azimuth. Azimuth is only given for which one? This is true north. That's it, nothing else. Okay, right. Select the answer. 167 question. This is already known, true meridian and magnetic meridian. Just now we have discussed, na? All of you. Arey, observe, Lina. Just observe. Just now I have drawn, na. Just now I have written that, na. Just before one question before this only I have done this. Just remember. Angle between which one? This is your true meridian or this true north. And this is which one? This magnetic meridian, or you can also call it as your magnetic north, right? What is this angle called as? This angle is called as your declination. Okay, this angle is called as your declination. Okay, it is not a dip, right? Dip is which one? Dip is which one? Dip is which one? Dip is a angle made by the magnetic lines, earth magnetic lines with horizontal. That is your dip, you can say. Yes, na? Now shall I move to the next question? 168. Select this. On 68 question. Raviraj said B and Lina said B, and any other answer by others? So generally, if you just observe all of you, let us say this is your which one? This normal one, you can say. This is your true north. Okay, and there is one line we are having, right? What is that line we are having? If you just say, this is your line AB, you can say, right? This is your line AB, you can say. And suppose if you just observe, let us say this magnetic north will be like this, right? What is this? You can say this is your magnetic north. What is this one? If you just observe, this is your magnetic bearing, na? This is your magnetic bearing. And what is this one? You can say this is your true bearing. Now tell me, what is that a true bearing? True bearing is equal to magnetic bearing plus that declination or minus declination. Magnetic bearing plus this theta. So true bearing if you wanted to get, right? True bearing if you wanted to get, magnetic bearing plus which one? This theta declination, na? Magnetic bearing plus this theta declination, or not all of you? Theta declination, you can say, right? Suppose if it is like this, in this manner. Suppose true bearing is like this only, right? True bearing, the true north will not change, na? That true north will not change, let us say, right? That true north will not change. So this is the line AB, which if you just observe, right? This is your line AB, you can say, and this is the line AB. Sorry, this is the line AB, you can say, and also what is that? You can say this is your true magnetic north. If you just observe, right? This is your magnetic north, and what is this angle? You can say this angle will be what? Magnetic bearing, right? From magnetic north, this angle will be magnetic bearing, right? This angle will be called with which name? Magnetic bearing. And from this true north, that angle will be called as your true bearing, if you just took, right? Now tell me, what is that a true bearing? You can say true bearing is nothing but your magnetic bearing minus theta declination, minus this theta declination or not? Yes, minus theta declination, right? Now tell me, it is towards west or towards east? That is declining towards west, and here it is declining towards west or towards east. You can say it is declining this towards east, yes, it is declining towards east, right? So what is that? You can say it is your eastern declination. So eastern declination positive, and this is which one? This western declination negative. Is that clear, everyone? Now a negative declination shows that magnetic meridian is to the western side of this true meridian. It is to the western side of this true meridian or not? Yes, western side of this true meridian, because here we are getting negative, there you are getting which one? This positive, you can say, right? Right, don't worry, that also will come, Raviraj. So we are having questions on that also, right? We are having questions on that also, right? Don't worry, Raviraj, right? Don't worry, we are having the previous questions on that also, that will discuss at that particular type question comes, okay? We are not missing that, okay? Because previous questions are there on that, means we will discuss definitely, right? So there are previous questions from that concept, don't worry, we will discuss at that appropriate time, right? Whenever the questions we are discussing, okay? Right, is that clear, everyone? Raviraj, we will discuss that, don't worry. So I will be closing the session now. Thank you all of you, right? Thank you all of you. Have a good day. Any doubts in our discussion till now? Don't worry, that also will be discussed, right? The sun at afternoon, that point will be having discussion, don't worry, okay? But we did not come across that question, we did not come across that question, once we come across that question, we will discuss definitely, right? No need to worry about anything, okay? Right. Yeah, okay, Lena, tell me what is your doubt in this discussion? Are you noting down? Okay, note it. Yes, dip means with respect to horizontal, right? This is your horizontal, and this is your horizontal, let us say, and your magnetic field is moving like this, so this vertical angle is only called as dip. Yes, that vertical angle is only called as dip. Yes, horizontal angle is your declination. Yes, Lina, correct. Any other doubt? Any other doubt by anyone else? Okay, thank you. I'll be closing the session. Thank you all of you. Have a good day. Again, we'll meet in the tomorrow's class at 8:30 p.m. same. 4:30 p.m. same. Okay, I'll be closing the session.